Hi, welcome to another video short in the Calculus for All video series. Today I'm going to introduce the concept of the derivative. Now, the derivative is at the core of calculus, and some would say even at the core of modern mathematics. And the definition of the derivative can be approached from two different ways. The first interpretation is more geometrical. That is, we've looked at it as representing the slope of a curve at a specific point. That is, we're going to calculate the slope of the tangent line to a function at a specific x value. And the other one is more physical. It's interpreted as the instantaneous rate of change. For example, the instantaneous velocity or the instantaneous acceleration. Historically, there was, and probably still is, a disagreement between mathematicians in which one of these two interpretations best illustrates the concept of the derivative, or which one is more useful. But we're not concerned about who is correct, for we've already derived a technique to calculate either one of these, and that is our famous limit definition. That is the limit as h goes to 0 of f of x plus h minus f of x all over h. This interpretation will calculate for us either the instantaneous rate of change or determine the slope of the tangent line. In either way, this limit definition is the definition of the derivative. Now, as we move along, we will find that mathematicians love creating symbols that mean it represents a process, a way of saying something in one symbol rather than write a paragraph or even a sentence or two. So rather than mathematicians say, let's take the derivative of the function f of x with respect to x, they will create a symbol that means exactly that. Now, different occupations that apply calculus will actually create their own symbols. I've got a few of the symbols that you will encounter during your journey that just means let's take the derivative. Each one has its pros and cons. Some are easier to write, but some of them give you some more detail on what we're actually dealing with. So as a starting mathematician, one of the things you should become familiar with is the varieties of the symbols used that represent, let's just take the derivative. Perfect. Now, just before we look at an example, the process of finding a derivative is sometimes called differentiation. So that may be useful when you hear people talking about derivatives. So we've got a function. I'll give us an example here. We're going to look at a function, and all I want us to do is take the derivative of the function f with respect to x. So what I'll do is write it in the terms that you may encounter in your textbook. So given f of x, which equals x squared, find f prime of x. So this just says, hey, a function is x squared, find the derivative of x squared, but do it in terms of the variable x. So we've had some experience with that. We'll just write our limit definition. We'll substitute x plus h into our function, and then substitute x into our function, subtract and divide by h. We'll expand, do some house cleaning. We'll get rid of those pesky 0 over zeros. We'll allow h to go to 0, and we in turn evaluate the limit as 2x. So what we've done is we have a function f of x which equals x squared, and we've discovered that the derivative of this function x squared is 2x. And because it's in terms of x, we can plug any value x into the expression 2x, determine the slope of the tangent line, or determine the instantaneous rate of change. Now, as we move on in the following video sequences, we're going to discover some amazing shortcuts that will be built upon our limit definition. So keep watching, and hopefully this was helpful.